Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Domain 5 of the Tech Plus certification, Data and Database Fundamentals, focuses on how data is generated, structured, stored, and applied in both business and IT environments. This domain accounts for 13% of the exam and covers essential concepts such as database systems, backup strategies, and analytics. A strong grasp of these fundamentals is critical for designing efficient systems, protecting sensitive information, and supporting informed decision-making. In this episode, we will introduce the core principles of how data gains value, how it is organized, and how it is accessed in real-world scenarios. Data holds significant value in IT and business because it underpins reporting, planning, compliance, and automation. In today's operations, it is considered a strategic asset across nearly every industry, guiding actions from marketing strategies to inventory management. Organizations rely on data to track performance, predict future trends, and optimize resources. When managed correctly, data improves operational efficiency, reduces uncertainty, and helps leaders make informed, measurable decisions that align with strategic goals. Understanding the difference between critical and non-critical data is essential for prioritizing protection and retention policies. Critical data includes information that directly affects safety, financial performance, or legal compliance, such as patient records or financial transactions. Non-critical data may include temporary system logs or duplicate files that do not have lasting importance. Proper classification ensures that resources are directed towards securing and preserving the most important information while optimizing storage for less essential content. Data capture and collection methods define how raw information enters a system, and this can occur in multiple ways. Manual entry, automated sensors, and data imports from other systems are all common methods. Information can be collected through web forms, application programming interfaces, or IoT devices, each suited to different environments. The accuracy and reliability of collected data depend heavily on validation processes and careful workflow design, as poor collection practices can lead to errors and undermine later analysis. Data correlation and reporting transform individual pieces of information into meaningful insights. Correlation involves linking related values across multiple datasets to identify trends, connections, or anomalies. Reporting tools then present this correlated data in summaries, charts, or dashboards that help decision-makers quickly grasp complex situations. By converting raw data into actionable intelligence, organizations can respond to emerging opportunities or address potential problems before they escalate. In business environments, data plays a direct role in shaping decisions at every level. Managers use performance data to evaluate efficiency, forecast demand, and determine where to allocate resources. Real-time dashboards keep key performance indicators visible, while historical records guide long-term planning and budgeting. Because data-driven decisions are based on objective measurements, they often carry more weight and credibility than decisions made on assumptions or incomplete information. Big data refers to extremely large and complex data sets that cannot be processed efficiently with traditional tools. These datasets often require advanced analytics, machine learning, or distributed computing to uncover patterns and generate value. Many companies monetize this data by improving services, targeting advertising more precisely, or selling aggregated insights to third parties. However, the value of big data depends on its accuracy, completeness, and ethical use, making transparency and privacy compliance crucial in monetization strategies. Analytics tools have become embedded in everyday applications, enabling organizations to process data for trend analysis, predictions, and recommendations. These tools appear in sales dashboards, customer behavior trackers, and operational performance monitors. By using visualizations and interactive reports, even non-technical users can explore data and draw meaningful conclusions. In IT, analytics support tasks such as troubleshooting system performance, optimizing workflows, and improving user experiences. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. A flat file is a simple way of storing data, usually as plain text or in a comma-separated values format, where each record is stored in a single line without structured relationships. While easy to create and manage for small datasets, flat files become inefficient as data grows and more complex queries are required. Databases, by contrast, store information in structured tables with rows and columns, enabling faster searching, filtering, and complex relational queries. For the Tech Plus exam, it is important to understand these differences and know when each method is appropriate. Modern databases offer a wide range of features designed to support both performance and security. They can handle multiple users accessing and modifying data simultaneously without conflicts, enforce permissions to control who can view or edit specific information, and validate data to ensure consistency. Built-in tools allow for regular backups and recovery, which are critical for business continuity. By organizing records into well-defined structures, databases improve efficiency and reduce errors in storage and retrieval. When comparing local and cloud storage for data, the choice often comes down to control, accessibility, and scalability. Local storage keeps data physically on in-house servers or devices, offering maximum control and potentially faster access in on-site environments. Cloud storage hosts data on remote servers accessed over the internet, providing scalability, built-in redundancy, and reduced maintenance demands. Each approach has trade-offs, and many organizations use a hybrid model to balance flexibility with security and performance requirements. Online access to data enables real-time updates, synchronization between systems, and collaborative work environments. Offline access, however, remains important in areas with limited or unreliable connectivity. Some software solutions support both modes, allowing users to continue working locally and synchronize changes when a connection is restored. Planning for network interruptions is part of good data management, ensuring that operations continue without disruption even in challenging environments. Data availability focuses on ensuring that authorized users can access the information they need without delays. This requires infrastructure that supports high uptime, redundancy to handle hardware or network failures, and optimization for performance under load. Reliability becomes even more critical in environments where delays can cause serious harm, such as medical systems, financial networks, or critical infrastructure. A strong availability strategy balances speed with backup and recovery capabilities to prevent data loss. Different types of data systems serve specific purposes in IT and business operations. For example, a point-of-sale system records and tracks transactions in a central database. A customer relationship management platform collects and organizes customer interactions, and a backup solution encrypts and stores copies of files in a secure cloud vault. Understanding these systems helps IT professionals plan for capacity, configure access controls, and ensure data is both secure and usable. On the Tech Plus exam, expect questions that test your understanding of how databases are used, how they differ from flat files, and how data is stored locally versus in the cloud. Scenarios may require you to identify structured and unstructured storage, explain database benefits, or decide on the best storage option for a specific situation. You should also be comfortable recognizing how data moves from capture through analysis in a complete life cycle. Key glossary terms for this topic include flat file, database, record, query, cloud storage, availability, analytics, correlation, and big data. Reinforcing these terms with concept maps or flashcards can help you associate each with its function, storage model, or user role. This active recall approach strengthens both test performance and real-world application. In IT practice, data fundamentals are applied every day. Support teams manage database permissions and troubleshoot access issues. Administrators configure availability settings to meet service-level agreements, and business teams rely on timely, accurate data to meet performance goals. A solid understanding of how data is structured, stored, and made available benefits every role in the IT ecosystem, from help desk staff to system architects. In the next episode, we will focus more closely on databases, examining how they are used in everyday operations, how they store and organize data, and what features make them different from simpler storage solutions. You will learn about database persistence, performance optimization, and how they support multiple users at once. Join us for Episode 46, Databases in Action, Usage, Speed, and Structure. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.